central line, which is the M line. Okay, so this is the M line. This band, which only has the thick filaments right in the center, this is the, what band is this? The H band. So the H band only has myosin filaments. This band, which has both the myosin and the actin, this is your zone of overlap, which we call as the A band. So very important for us to know these bands on the model also. And where you have only the thin filaments here, this is your I band, you'll have the same structure on this side as well. So this line is called your Z line. So this portion of this this muscle cell between the two Z lines, so you can see this portion between the two Z lines, this entire portion, this entire model, this is one sarcomere. So this entire model is representing one sarcomere because it is showing the portion of your skeletal muscle cell between the two Z lines. Is this clear what this model is representing? Okay, so now let's look at what these structures, the thick and the thin filaments, are looking like. So I'm going to zoom in and I'm going to show you just one portion of the sarcomere. So you can see right here, these red balls, these are your globular actin. Together these are forming your filamentous actin. The yellow lines, if they are visible to you, these are your tropomyosin. So rope-like protein which will hide the active binding sites of your actin. The tropomyosin is controlled by these green proteins that you can see, these ball-like proteins that you can see, which are representing the troponin. So when calcium is released into the sarcomere, the troponin will bind to that calcium. It will twist, it will change its structural conformation in such a way that it will cause the tropomyosin to move away from the active binding sites of the actin. At that time, the head of the myosin, which is shown here, so you can see the myosin filaments right here, you can see the two bobbing heads from each of the myosin molecules, 200 to 300 myosin molecules present in each of these thick filaments. The head is charged with an ATP molecule, so it has an ADP and PI present inside the head. With that energy, it will bind to the thin filament, and so if it's spread out, it will bind to the thin filament and it will pull the thin filaments closer to the central M line. So what's important right here for us to understand is that none of the bands which are present in the center, for example the H band, they do not change in their diameter, so that remains the same. All that is happening is that the myosin heads are binding to the actin and are pulling the actin filaments towards the central M line. As they're pulling it towards the central M line, the two Z lines on the two sides are actually coming closer to each other. So you have one Z line coming close on this side, you have the other Z line coming closer on that side. So that reduces the size of the sarcomere, that causes the contraction of your muscle. Okay, so from this model we ask you questions such as, asking you which is the M line, which is the H band, which are the Z lines, where's the actin, where's the tropomyosin, where's the troponin, where's the myosin, questions from the sliding filament theory. So overall, knowing where the bands, where the lines are, what happens during the muscle contraction, that is what you are supposed to know. Also knowing that the space between the two Z lines is called the sarcomere.